Hello and welcome to The Space Above Us, Episode 6, Project Mercury Flight 4, Aurora 7, Fireflies, Space Balloons, and Friendly Fish. Last time, we talked about the triumphant flight of John Glenn aboard Friendship 7. The mission had accomplished the primary goal of Project Mercury by launching a human into orbit and safely recovering him. Despite some technical hiccups, the flight was a complete success, but was a little light on the science front. Since there were already so many unknowns on America's first orbital flight, most of the requests from scientists were put on the back burner in favor of keeping the flight as simple and predictable as possible. This next flight would change that. Mercury Atlas 7 was originally going to be flown by astronaut Donald Deke Slayton, but he was suddenly replaced about 2 months before the scheduled flight. Slayton was removed from flight status due to a concern over a mild heart condition called idiopathic atrial fibrillation. Basically, every once in a while, Slayton's heart would have a minor flutter. NASA had actually been aware of the condition since 1959, when it appeared during a centrifuge test. NASA doctors said that the condition was no cause for concern and should not be a detriment to Slayton's performance as an astronaut. Unfortunately for Slayton, this was not the end of it. Over the ensuing years, there were a number of other inquiries into the status of his heart and its impact on his suitability as a Mercury pilot. Time and time again, doctors concluded that there was no problem. After enough asking, though, eventually a few doctors said that they couldn't definitively say that it wouldn't cause a problem. James Webb, the administrator of NASA at the time, concluded that the appropriate response was to remove Deke Slayton from active flight status. The decision was devastating to Slayton, but the cold hard logic of it made sense. The United States was taking its first tentative steps into a new frontier. Questions and uncertainties loomed over every aspect of spaceflight. With 6 extremely qualified pilots available who did not have a minor heart condition, why add one more variable to the equation? Don't worry too much about poor old Deke, though. This is a bit of a spoiler, but we'll be seeing him again a few episodes down the line for the Apollo-Soyuz test project. In the meantime, he settled into his role as head of the astronaut office. Oh, and just as a fun fact, Slayton said that had he flown the mission, he would have named it Delta 7. Instead of Slayton's backup pilot, Wally Schirra, Scott Carpenter was tapped to fly the mission, since the flight was coming up soon, and Carpenter, who had served as Glenn's backup, was more up to date on his training due to the lengthy delays of Mercury Atlas 6. The flights were scheduled so closely together, since it was not known if Glenn's flight would be a success, so the follow-up flight was scheduled just 2 months later to ensure Project Mercury's primary goal would be accomplished as soon as possible. Malcolm Scott Carpenter was born on May 1st, 1925, in Boulder, Colorado. Like his fellow astronauts, Carpenter was a military pilot, having joined the Navy in 1949 and flown a variety of missions in the Korean War. After the war, in a move that is starting to sound familiar, he attended test pilot school and started work testing new Navy aircraft. In 1957, he began 2 years of training to become an air intelligence officer and served on the USS Hornet. During their training in the build-up to the first flights in Project Mercury, the astronauts picked specialties in order to better understand their spacecraft, booster, and mission. Carpenter specialized in communication and navigation. Since I didn't mention it in their episodes, and you may be curious, Alan Shepard chose tracking and recovery operations, Gus Grissom chose the attitude control systems, and John Glenn chose cockpit layout. As usual, Mercury Atlas 7 came with a number of minor changes to the capsule. The Earth Path Indicator was removed from the spacecraft since its considerable heft wasn't worth the information it provided. Also removed were a number of recovery aids since the recovery operations had been going so smoothly. There were also some changes made to the astronauts' equipment. The knee and chest straps were removed, while pockets were added to the upper arm and lower legs of the spacesuit. Carpenter was also the first astronaut to enjoy a cushier liner to his seat to prevent the considerable discomfort that accompanied waiting hours for launch on one's back. For this mission, Aurora 7 carried specialized equipment for the astronaut to perform a number of science experiments. My favorite of these was a colorful balloon that was to be deployed from the spacecraft, inflated, and towed behind the vehicle. The purpose of this experiment was to help judge the visual acuity of the astronaut and reflectivity of sunlight with regards to the various colors and materials of the balloon, while also using the tension of the tether to quantify the atmospheric drag at this extreme altitude. The balloon was about the size of a beach ball and was made of differently colored sections: yellow, orange, white, metallic aluminum, and a phosphorescent color that changed with the lighting conditions. It would be deployed at the end of a 100-foot-long nylon cord and towed behind the spacecraft. The balloon is my favorite because I can't help but imagine the capsule as a little kid towing a colorful balloon while running down the sidewalk. Another experiment was intended to shine some light on the behavior of fluids in a weightless environment. Having a firm understanding of such behavior was important, since almost all spacecraft have a fair amount of liquids in critical systems, including attitude control, thermal management, the large rocket engines used in later spacecraft to change their orbits. It's really all over the place. 2 more experiments were related to atmospheric phenomenon. One was an examination of the air glow layer of the atmosphere, and the other was simply for the astronaut to take photos of weather systems using his handheld camera. Air glow is a faint illumination of the upper layers of the atmosphere, caused by a few different sources. When sunlight hits the upper atmosphere, it can knock electrons in the atoms of the air into a higher energy state. When these electrons drop back down to their natural energy state, they release light. Cosmic rays from deep space hitting the upper atmosphere creates light in a similar way. Air glow means that even on a moonless night in the middle of nowhere, an astronomer would still have to contend with a certain amount of visible light, so it's important to understand its properties. Lastly, Carpenter was to repeat Glenn's attempt to observe a bright flare fired from the surface at night, but this time use an instrument to try to quantify the amount of light reaching the spacecraft. If this sounds like a lot of stuff to manage while keeping America's second manned orbital spaceflight running smoothly, then you share the concerns of the astronauts themselves. Additionally, the flight plan changed many times in the build-up to launch, preventing Carpenter from training effectively. As we will see, the packed flight plan would be a contributing factor to the problems encountered during the build-up to re-entry. In addition to the numerous scientific goals, it was also hoped that this flight would see an end to the attitude control problems that had troubled the previous 2 flights, as well as improve on fuel efficiency. As you recall from the previous episode, Friendship 7 had run out of fuel in both the automatic and manual attitude control systems as it re-entered the Earth's atmosphere. While the capsule splashed down with no issues, this was a cause for concern. On May 24, 1962, at the early hour of 1:15 a.m., Scott Carpenter began his day. The astronauts always seemed to get the best breakfasts, and today was no different. Carpenter enjoyed a breakfast of filet mignon, poached eggs, orange juice, toast, and coffee. I don't think I mentioned this in the previous episodes, so in case you're wondering why the astronauts were required to wake up at such an early hour, it was because NASA wanted to launch as soon after sunrise as possible. That way, recovery forces would have more time before sunset to locate the astronaut in case he didn't land in the expected areas. Shortly after breakfast, he made his way to the launch pad, accompanied by fellow astronaut John Glenn. After taking a moment to greet members of the closeout team, he entered his spacecraft. This time, all 70 bolts on the hatch worked without a hitch. The countdown to liftoff went smoother than previous attempts, with no technical issues and just 45 minutes of unanticipated holds due to weather. The new seat lining was apparently doing its job, as Carpenter had no trouble with discomfort during the build-up to launch. At 7:45 a.m., Aurora 7 rose from the launch pad, carving a hole through the early morning Florida haze as it made its way into orbit. Unlike the previous flights, the ride remained smooth even through the period of maximum dynamic pressure. Carpenter commented on the rapidity of the transition from blue to black sky. Just over 5 minutes after the powered flight portion of the mission began, the Atlas sustainer engine shut down and the capsule separated from the booster. Immediately after spacecraft separation, Carpenter took manual control via the fly-by-wire system and rotated the capsule around such that its heat shield faced the direction of travel. The turnaround took less time and used less than a third of the fuel compared to the automatic procedure used during John Glenn's mission. Despite rotating 180 degrees while traveling at 17,500 miles per hour, Carpenter said he felt no sensation of motion at all. At the start of his first orbit, Carpenter tracked the silvery Atlas rocket as it tumbled away from his capsule. It left a stream of ice crystals that appeared as white smoke as it traveled beneath him. As the astronaut passed over Nigeria, the first indications that the cramped schedule may be problematic were radioed down. Carpenter was having trouble loading film into his handheld camera in order to complete an experiment to photograph the Earth horizon. While he was able to fire off a few photographs before orbital sunset, this would set the tone for the rest of the flight. As the capsule moved into the Earth's shadow, Carpenter attempted a number of astronomical observations. However, between the relatively short duration of orbital night and the bright light of the control panel, Carpenter found that he had trouble getting his eyes to adjust to the darkness. He stated that the periscope was useless at night, that he couldn't see the stars all that better than a good dark night on Earth, and did not find the stars very helpful for orientation. Just as on the previous flight, attempts to view bright flares fired from the ground were hampered by cloudy conditions. As the spacecraft passed through orbital sunrise, the mysterious fireflies returned. While not an official goal of the mission, there was much interest in this strange phenomenon, and it was hoped that Carpenter could get to the bottom of it. The mystery would indeed be explained on this flight, but not until the third orbit, so I'm going to leave you in suspense just a little longer. Scott Carpenter's first orbit around the Earth had gone fairly well, but there was concern about the rate of fuel use. After one orbit, the fuel for the automatic system was down to 56%, and the manual system was down to 64%. At that rate, Aurora 7 would be completely out of fuel near the start of its third orbit. The alarming rate of fuel use was partially due to the fact that as Carpenter moved from experiment to experiment in the cramped capsule, it was easy to bump the hand controller. This issued a command to the attitude control system, which not only wasted fuel on an erroneous thruster firing, but required an opposite thruster firing to bring the capsule back to the desired attitude. Fuel was also being used to swing the spacecraft around to the attitude required for different experiments. Some might require the astronaut to look straight down on the Earth, or at the horizon, or out into space. Later missions would optimize the experiment schedule to minimize fuel usage. Speaking of experiments, it's time to release the space beach ball. Shortly after starting the second orbit, the multicolored balloon was released from Aurora 7. It only partially inflated, but soon began to wander away from the capsule. Instead of trailing behind the spacecraft at the end of a taut line, it just sort of wandered all over the place while slowly bouncing at the end. The line would be tight, then snake all over as the balloon wandered, and then tighten up again. The line eventually wound up wrapped around the antenna portion of the spacecraft near the front. The pilot released the line in the hopes of getting rid of the balloon, but it stayed with the vehicle for the entire flight, before disappearing without notice sometime just before re-entry. Space balloons are tricky to predict. The second orbit saw less fuel use, but still more than was desired. Carpenter performed a number of attitude changes, including the first inverted flight, where he rolled the capsule such that his head pointed towards the Earth, which he found quite comfortable. In addition to the numerous intentional attitude changes, Carpenter continued to accidentally bump the hand controller during other activities, wasting precious fuel. As he passed over Florida and began his third and final lap around the planet, Carpenter was instructed to leave the spacecraft in drifting mode as much as possible to conserve fuel. As he passed over the Canary Islands for the third time, the famous fireflies reappeared, and it was finally time for the mystery to be solved. Carpenter noticed that when he bumped the interior of the tiny spacecraft, it caused a new flurry of fireflies to appear. To test his theory, he knocked on the interior of the hatch, and sure enough, a new burst of fireflies came into view. Far from being some mysterious new space creature, they turned out to be simple, if beautiful, ice crystals that were coating the exterior of the vehicle. This portion of the flight would perhaps come back to haunt Scott Carpenter, as it caused a fair amount of criticism after splashdown. In his excitement to better explain the origin of the fireflies, Carpenter began to rotate his capsule around to get a better look. At this point, near the end of his third and final orbit, fuel was approaching dangerously low levels, and the all-important preparations for re-entry were imminent. Instead of conserving fuel, staying on task, and preparing to execute this critical series of actions, Carpenter was distracted and performing maneuvers that were not in the mission plan. As he passed over the Hawaii ground tracking station, he struggled to get back on schedule. In his haste to prepare the capsule for its return to Earth, he mistakenly left the manual control mode on after enabling the fly-by-wire control mode. This meant that every time he moved his hand controller, both systems would activate, creating more thrust than necessary and wasting fuel rapidly. The build-up to retrofire was complicated by the fact that partway through the flight, it was discovered that the sensor measuring pitch angle was off by 20 degrees. This meant that the retrofire would have to be completed manually. Several times during the re-entry checklist, Carpenter had to be reminded to perform critical actions. When the moment for retrofire arrived, Carpenter believed that it was going to happen automatically and hesitated for 2 seconds before pressing the button himself. This quote is a bit long, but I'm going to read the whole thing to allow Carpenter himself to explain the events leading up to the retrofire. Quote, "I think that one reason I got behind at retrofire was because just at dawn during the third orbit, I discovered the source of the space particles. I felt that I had time to get that taken care of and still prepare properly for retrofire, but time slipped away. The Hawaii Capcom was trying very hard to get me to do the pre-retrograde checklist. After observing the particles, I was busy trying to get aligned in orbit attitude. Then I had to evaluate the problem in the automatic control system. I got behind and had to stow things haphazardly. Just prior to retrofire, I had a problem in pitch attitude and lost all confidence in the automatic control system. By this time, I had gone through the part of the pre-retro checklist which called for the manual fuel handle to be out as a backup for the automatic control system. When I selected the fly-by-wire mode, I did not shut off the manual system. As a result, attitude control during retrofire was accomplished on both the fly-by-wire and the manual control modes. At the time, I felt my control of spacecraft attitude during retrofire was good. My reference was divided between the periscope, the window, and the attitude indicators. When the retro attitude of negative 34 degrees was properly indicated by the window and the periscope, the pitch attitude indicator read negative 10 degrees. I tried to hold this attitude on the instruments throughout retrofire, but I cross-checked attitude in the window and the periscope. I have commented many times that on the trainer you cannot divide your attention between one attitude reference system and another and still do a good job in retrofire. But that was the way I controlled attitude during retrofire on this flight. Although retro sequence came on time, the initiation of retrofire was slightly late. After receiving a countdown to retrofire from the California Capcom, I waited 2 seconds and then punched the manual retrofire button. About 1 second after that, I felt the first retro rocket fire. If the California Capcom had not mentioned the retro attitude bypass switch, I would have forgotten it, and retrofire would have been delayed considerably longer. That was a long quote, but I liked it. As Aurora 7 passed over Hawaii before the re-entry preparations, it still had nearly a third of its manual fuel remaining. But due to the pilot's mistake in leaving the manual control system enabled when switching to fly-by-wire, it quickly drained entirely. Speaking with Alan Shepard as he flew over California, Carpenter said, "I am out of manual fuel, Al." The astronaut saved the precious little automatic fuel remaining and waited until mere seconds before the retrofire to ensure the vehicle was in proper orientation for entry. Before re-entry even began, controllers on the ground realized that Aurora 7 would be landing nearly 300 miles past the expected splashdown zone. About 200 miles of that was due to the fact that the capsule was accidentally yawed 25 degrees to the right, about 17 miles due to the 3-second delay in initiating retrofire, and another 70 miles due to lower than expected thrust from the retro rockets. As Aurora 7 began its plummet towards the ocean, Carpenter had to be reminded to both retract his periscope and close his faceplate, actions which he had neglected to perform. Despite the haphazard preparations, re-entry mostly went smoothly. Since the vehicle quickly ran out of fuel, it had similar wild oscillations to Friendship 7, and Carpenter too deployed his drogue chute early in hopes of stabilizing the capsule. 4 hours, 56 minutes, and 5 seconds after launch, Aurora 7 splashed down in the Atlantic Ocean, and nobody was around for miles. After splashing down, Carpenter attempted to raise recovery forces on the radio, but received no response. His last transmission from Mission Control told him that it would take about an hour for someone to get to him. Not wanting to risk a repeat of the Liberty Bell 7 sinking, especially with no one around, Carpenter began the more laborious process of exiting via the spacecraft's nose. This required removing some control panels and climbing through a cramped passage where the parachutes used to be. He carefully extracted himself from the capsule, lowered himself into the water, and inflated his life raft. As he got comfortable and began to wait for recovery forces, America's latest spaceman realized he wasn't entirely alone as a, quote, black fish that was just as friendly as could be swam around the raft. Scott Carpenter had landed hundreds of miles off target, but thanks to the high-quality positional data from the tracking network, his position was known to within a few miles. Additionally, the recovery aids were functioning properly. Green dye had been released into the ocean to make Aurora 7 easier to spot from the air, and a recovery beacon had been enabled. A little more than half an hour after splashdown, 2 airplanes flew overhead, circling the area. A little later, several cargo aircraft flew overhead. 2 rescue frogmen parachuted out of one of the airplanes, but the astronaut didn't notice. So you can imagine his complete surprise when one of the rescuers swam up and called out to him. Carpenter replied, "How did you get here?" The astronauts' new companions inflated additional life rafts and helped secure the bobbing spacecraft. Carpenter offered the men a snack from his onboard rations, which they declined, but they did accept a sip of water. The 3 men waited for the main recovery force to arrive and retrieved various rescue aids that were dropped from passing airplanes. One contained a flotation collar for the spacecraft to further stabilize it, and while they expected the next package must contain a radio, to their surprise and annoyance, only a battery was discovered inside. Finally, over 3 hours after splashdown, Scott Carpenter was retrieved by a Navy helicopter. In the process, he was dunked in the ocean, though he did manage to hold his camera above the water, and after boarding the helicopter, proceeded to cut a hole in his suit's boot to drain the water. The flight of Aurora 7 was over, and by most measures was a complete success. More science had been accomplished on this mission than any previous flights. The capsule had mostly worked perfectly, and the astronaut was safe and sound despite an off-target landing. However, questions were quickly raised about Scott Carpenter's performance. His decision to perform unplanned attitude changes to investigate an unexpected phenomenon forced him to rush the pre-retro fire checklist. His haste to complete the checklist likely contributed to a series of neglectful mistakes, the most critical of which was enabling 2 control modes simultaneously, thus depleting his manual attitude control fuel supply. Had the automatic system also run out, the astronaut would have had no way to orient his vehicle for the all-important retro burn and re-entry. Additionally, had Carpenter been more careful about bumping his hand controller while performing his assigned tasks, there may not have been such a critical fuel situation in the first place. Personally, I'm conflicted about the criticism Carpenter received. On the one hand, this was only the second manned flight of a complex and finicky system with thin margins, so it made sense to stick strictly to the mission plan. On the other hand, time and space is rare, and who is to say if any future astronauts would be able to replicate the Firefly phenomenon? While it turned out to be simply ice crystals, there was no way of knowing if this was an important or dangerous situation for future missions. One of the main benefits of having a human on board is that they can exercise judgment that is impossible for a machine or even a human on the ground. That being said, I think Carpenter probably could have played things a little safer given the nature of his flight, and he is lucky that the biggest problem with his re-entry was simply an off-target splashdown. In addition to the accidental hand controller motions and the unscheduled attitude changes, Carpenter also forgot a number of critical actions and had to be reminded. Spaceflight is incredibly complicated, so a small number of mistakes is perhaps understandable, but space does not tolerate mistakes well. Astronauts need to be held to a higher standard. The reason I bring up this criticism of Carpenter's performance is that while there is no direct causative link, Scott Carpenter became the first astronaut to fly in space only once. In 1963, he took a leave of absence from NASA to participate in the Navy's Sea Lab project and was later involved in a motorcycle accident with sufficient injuries to remove him from flight status. Though it seems somewhat likely that even without the motorcycle injuries, he may have never flown in space again, for reasons similar to the grounding of Deke Slayton. By the time Project Gemini began, NASA had 16 astronauts to choose from. Why choose the one who had proven he was capable of making mission-critical mistakes when there were others who hadn't? Due to his injury, we'll never know for sure. The flight of Aurora 7 had replicated the feats performed by Friendship 7 while expanding on them with a slew of science experiments. And while it had its own share of problems, once again an American had orbited the Earth 3 times and was recovered safely. For the next mission, science would take a back seat and engineering would take priority for Wally Schirra's 6th orbit flight of Sigma 7. Ad Astra, catch you on the next pass.